All right, hello and welcome. In this example, we're going to calculate the period of the following frequency values. Right, and so down here, I gave another diagram here that shows a sine wave. That's our oscillation there that we're going to use. And we have a 90 degrees at the top. So when we say we're 90 degrees out of phase, we expect it to shift up to that degree phase angle. And so we'll see that that can also result in additional waveforms following just after ours. And this would be a 90 degrees phase shift, right? So when we talk about 90 degrees, we're talking about that phase shift. And that's only 1/4 of our period at that point. And so as we continue around here, we'll see that the entire period happens over one full cycle when we rotate not just 90, but a whole 360 degrees, right? And that rotates around a circle, right? So it's kind of like we've flipped this side over here in our circle. And so this is our negative side, and this is our positive side of that circle, right? So we'll use that concept here to explain the time that that's going to take. And so we'll say that we have X amount of cycles that happen, and those cycles are described in terms of the period, the time that that cycle occurs in, right? And so now we've got two factors to describe the same waveform here. And we can also call it 2 pi in radians or in degrees, as in a 360 phase. So we can also describe the same time value, the period, as a frequency, right? That's what we're doing here. We're saying that we have a frequency value that replicates the value of this period in a different form, and we can convert it back and forth. And sometimes we can only read the period. Sometimes we can only read the time that that cycle happened in, and that's going to be like on our oscilloscopes. And so we need to take the time that we have and turn it into frequency, and sometimes we need to take the frequency we have and turn it back into time so that we can see what signal we're actually looking at. So that's what we're going to use this for. And we're going to use the t equals 1 over f, and that's the inverse of frequency, right? Time is equal to the inverse of frequency. And we'll see that that is also the same thing as taking f to the -1. So either one of these two calculations will get you time out of your frequency. So we're going to plug that in for this first one here. We'll say that we have 12 or 1.2 kilohertz. And so we'll move that out. We'll say that's 1 over 1,200. That's that 12 or 1.2 there. And we'll say that our time value for this frequency is actually equal to, that's not engineering notation, so we want to move that into engineering notation, right? And so we'll take that 0.83 and move it back 2 spaces to get to the -6 spot up there from our -4 location. So that happens over here. We'll say that we actually have 833. And that's at -6. So we'll say microseconds, right? It's a time factor, so it's in seconds. Before it was in hertz, but now we're in seconds for this. Right. And that would be one cycle, right? One cycle occurs in this length of time for this frequency value. And that is what we want to know from these. Okay, so this other one over here, we have a similar concept going on, except we're in megahertz. And so we need to account for that one in our calculation over here. And we can do that in notation also. We can say that we have, let's erase this part. We have 1 over, and then our notated value of 6.8 times 10 to the +6. That's our mega ohms or million ohms there. And so now we can write that out and say that's our answer, but it's in -7, right? That's not engineering notation, so we need to move that back to a factor of 3. We can go forward, but that gets us a really, really small number still. And so we'll move it backwards. We'll move it to the -9 instead, right? So we'll say that's 147 times 10 to the -9, and that is equal to, and that's in seconds, 147 nanoseconds, right? Really small numbers that we're working with here. That's why that frequency can be really helpful for us, because it won't scale our equations into the negatives further. It'll keep us in a reasonable time. All right, let us know if you guys have other questions.